Hi everyone and welcome. Today we are going to be talking about algebraic two-column proofs. So your goal after watching this video will be able to clearly define and solve algebraic two-column proofs. So before we start off, what is a proof, generally speaking? We will define this in our math vocabulary in a moment, but from a big picture, a proof is just when you take something that's given to you and you reach a conclusion. So if anyone I know that Amanda Knox documentary has been trending on Netflix. If anyone's seen that, it focuses quite a bit on the legal side, and one of the most common places where proofs are used is actually in court. So if you want to take information and reach a conclusion in court, you need to carefully go through, basically line by line with other statements, like this diagram is showing us here, to reach your conclusion. So we can't just start off with, a small piece of information like, there was a piece of DNA from this person, and then immediately go, the next sentence that you say is, so therefore they murdered this other person. In order to get from that DNA to proving that, that murder actually happened, you need to go step by step and make sure everything adds up. So the Amanda Knox case, if you want to apply that to proofs here, so what happened was Amanda Knox's roommate, she was a study abroad student, was murdered when she wasn't home. Amanda Knox's DNA was found around the scene of the crime, and therefore Italian prosecutors said, okay, Amanda Knox was involved in the murder of her roommate. So Amanda Knox was actually exonerated, or she was proven innocent of this, because basically two things. So number one, her lawyers were able to take the given statements of Amanda Knox's DNA was found at the murder scene and say, one, that's her apartment, of course her DNA is there, and two, the DNA analysis that was performed was deemed to be contaminated or inaccurate. So they took those two statements and said, therefore, because she lived there and because the crime scene DNA analysis was inaccurate, Amanda Knox is innocent. So that would actually be an example of a proof. So you take pieces and you make conclusions, but you can't jump steps. So you got to show everything piece by piece how it got there. So sorry if I just ruined the plot of that documentary for you, but again, I tend to think of court when I think of proofs, because in law and in legal jargon, every single piece has to be proven step by step. We can't just jump ahead and make big conclusions. So our definition for today that we're going to be looking into is actually two-column proofs. And a two-column proof is a method to prove statements using properties that justify each step. So two columns because, you guessed it, it has two columns. So on the left side, we have our statement, and on the right side, we have our proof. So for an example like this, 2x equals 8. We start off with this as our first statement. It is given. So they just tell us that. So we write the word given to just state the things that we already know. So that's that given statement. That's the initial information. And from there, every single little thing that we do, we have to say why we do it. So here, we divide by 2 on both sides. That's actually called the division property. Just put a 1 there, actually. So division property. And using this division property, we get to x equals 4, which is the conclusion that we're looking for. So basically, all that this is saying is every single little thing we do, every subtraction, every addition, multiplication, division, substitution, any operation you do at all that changes what you're given, you just have to say what you're doing as you're doing it. So I know proofs might sound scary and even look scary, but all we're doing is we're just also writing out in words what we're doing right next to the math that we're doing. Today, we're going to focus on algebraic examples, or just solving equations using proofs. So something that we're familiar with, going through doing our inverse operations and everything that we're used to with getting variables alone. And the only difference today is we're going to write out why we're allowed to do each of those steps. So if you're wondering, where did, Mr. Reardon just get that division property from? So I created this list here that we are absolutely allowed to use, and I would say 100% keep this in your notes, keep this handy. As you're doing these questions, even have this on your screen somewhere, written down somewhere, These are the main properties that you're going to use for algebraic proofs as you go through. So addition property means if you add the same thing to both sides, the equation stays balanced, you're allowed to do that. Subtraction property, same thing. If you subtract the same quantity from both sides, if you subtract c from both sides, again, we maintain balance, we're allowed to do that. The same goes for multiplication and division. Again, if you do the same thing to both sides of the equation, to every single term, it stays balanced, we're allowed to do that. So 1 through 4, just using our basic operations, keeping balance, doing it to the same sides. Distributive property is just saying that we are allowed to multiply the terms inside of the parentheses by the term on the outside. So if we have a times b plus c, we're allowed to do a times b plus a plus c, plus a times c. Finally, substitution. This is just saying that if a equals b, we can interchange a and b fluidly wherever we want to. So if we see an a somewhere and we know that a equals b, we can plug in a b instead. It's not going to change the balance because they're the same thing. And the same goes for the symmetric property. If you have something on the left and you'd rather it be on the right, you are allowed to completely flip everything on the left side to the right side as long as you do the same thing from the right side to the left side. So these are the basic properties that we're going to be using today. These go along with solving algebraic equations. And again, what I would say is keep this handy in your notes. I know that some of us have, like, on the front page of our notebooks had common examples of like the angles from last chapter. These are going to be our new angles, right? So keep these handy, keep them ready for us, and we'll be good to go. All right, so we're going to do 2 examples together. I'll leave the remaining, I think there's 3 other ones outside of this for you to get some practice going through and doing. So first things first, always write the given. So whatever you're given, just write it down to start. Don't even think about it, just write it on in. So writing down our equation because that is given. Our next step here, we can, let's see, maybe let's move all of our x's to the left side. So subtract 3x on both sides, and we'll be left with 1x plus 2 equals -6. We can go back to that chart and use the subtraction property because we subtracted the same thing from both sides. And our last step here, we can subtract 2 on both sides. We'll be left with 1x equals -8 as our final statement. And we can say that we did this again, actually using the subtraction property. So you'll notice I'm kind of writing out these steps in the middle between the lines here. Those between the line steps, that's what's justifying what we're actually doing. So step number 2, we did subtraction to get there. Step number 3, we did subtraction again to get there. And again, writing it out clearly, proving every single step of the way, that's what makes this an algebraic proof. All right, again, write out what we're given for our next question. And again, our reason is it is given to us. Let's start off with our distributive property. So 6x minus 12 plus 4x equals 18. The reason that we are allowed to do this is because of the distributive property. Next, we can combine like terms. So 6x and 4x, we can call that 10x minus 12 equals 18. And we can just say that that is simplifying. So that's not a new property, but we can just say that we are simplifying. Next, let's add 12 to both sides. And we're left with 10x equals 30. We can say that was, again, we added the same thing to both sides. That is the addition property. And then our last step, divide both by 10. We'll be left with x equals, make sure I got that right here. Yep, x equals 3. And that would be, again, with our division property. All right, so again, no big changes here in what we're doing. We're still carefully going step by step. We're still showing all the same steps that we've been doing on all of our quizzes and tests so far this year. The only difference is now with these proofs, whenever we're doing something between our lines here, we're just writing out the reason for why we did it. So again, keep those notes handy. I would definitely say keep those list of properties that you're allowed to use for proofs. It's going to help you out quite a bit. And let's finish up the remaining 3 questions here. As always, thank you so much for tuning in. If you have any questions, let us know. We're